So, hi, good morning. Thank you for attending this session, and thank you, Arianna and Riccardo, for your kind introduction and, more importantly, your invitation to participate in this interesting session. It's my pleasure to open up this session with two talks. So, I'm afraid, apologies, that we are going to listen to me for 40 minutes. But I'm going to present research that I hope you will find useful, that Francesca and I are doing at the Italian Space Agency in the Scientific Research Unit. The first talk will be more an overview of the current digital methods that the archaeological remote sensing community is using at the moment to track looting, to monitor and quantify this phenomenon. The second one will be instead a more focused paper on a case study in Syria that Francesca and I have studied for 5 years now. So we all know what archaeological looting is. So it's something that is happening. And I just linked to Arianna's presentation. It's something that crisis, political instability situations, warfare can favor. But it's just important to know that archaeological looting is something happening also in ordinary times, and is linked to economic, social, and cultural factors of the country where this phenomenon occurs. You may think that it occurs only in poor and developing countries. That's not true. Probably already you have seen in Arianna's presentation a UNESCO map showing the trafficking routes, which basically matches with this map. That's only a sample of situations that we have found recorded in social media rather than in scientific publications or in the grey literature. And as you can see, it's pretty ubiquitous. And you can imagine why remote sensing is very helpful to track this phenomenon, to quantify its spatial and temporal spread from remote. The talk is about towards best practices. I'm not going to give you today best practices, but I'm going to outline the current state of the art and the situation where we are at the moment as a community in terms of digital methods in remote sensing and image processing, based on which Francesca and I think that we are in the position to move as a community towards best practices. Talking about communities is a pretty vital community. It's made by both scientists with different degree of expertise in image processing, but we have also practitioners. In a second, I will show you some projects around the world where practitioners are fully involved in using these remote sensing technologies. Because at international level, we have already a common understanding of the usefulness of these technologies as an objective source of information, allowing a conservative estimate of their condition on the ground. So there's no doubt about that in the community. But interestingly, different groups are using different data, and this reflects the fact that we have a plethora of satellite space missions that are providing data. There are different methods that at first approximation we can subdivide in manual, visual, image processing based, and automated or semi-automated. And I can tell you in the community we are debating the degree of automation versus just the image processing based methods. For sure, in terms of mapping archaeological looting, there are established methodology. Arianna was mentioning before, IAMINA is one of the best examples at the moment in the international community where we are establishing methods, calculating also the accuracy and the error that we tend to make when measuring looting. But there's something interesting at the moment that probably we need to work on more. sharing knowledge and consolidating methods. Interestingly, I will show you some example later on. Different groups have developed different methods, but we have the evidence that at the moment these methods are poorly disseminated across the community. So outside the group that have developed these tools, we are still a few evidence that they have penetrated in the community. Ariana was referring to political instability events that may trigger looting or favor the spread of looting. It's interesting. We are doing this study and hopefully it will be published soon. We have tried to correlate the trends in the specialist scientific research publications with some of the key events recalled in the previous presentation. And this is a confirmation that looting is happening anyway. And there was already back in the early of this century an interest in research groups in developing methods based on satellite data to measure looting, to monitor looting. So as you can see, the trend is continuously growing. So we have more and more publications. And in some way, the events that have made this phenomenon pretty known across the social media have generated an impact in increasing the attention and therefore the use of satellite data. But to be honest, this is something that was already ongoing. I was mentioning before some of the projects. So EAMINA in the UK, but also ASER in America, Antiquities Coalition, UNITAR, several projects, several international initiatives that are using satellite data. But interestingly, we are not limited and constrained in just observing this phenomenon. We are moving as a community to interpret the observations that we are making. Interestingly, the outputs are pretty different depending on the scope of study and also the scale of the observations. So I just report here 3 examples from the very recent scientific literature. And as you can see, we have examples in the top left, an anthropology study based on the evidence of severity of looting across the whole country of Syria, linked to the various type of occupation or groups that have been the major players in looting. But also there are studies trying to predict the extent and severity of this phenomenon. So you can see that observations is just the starting point towards a more interpreted output. Moving to satellite data. In the study that we have just submitted, we have analyzed all the publications starting from 26 up to date, just to see how different data from space missions are used. Of course, the majority is optical data, so in the visible bands of the electromagnetic spectrum, mostly from commercial providers like Digital Globe at very high resolution. Most of these studies propose the use of this data with a clear defined methodology for mapping, which is mostly based on manual mapping and visual detection and identification of looting features. Still, few publications are dedicated to combine optical data and radar data from Synthetic Aperture Radar space mission, and even less publications are using radar data at very high resolution, less than 1 meter or 1 meter, to develop an automated or a semi-automated method for identification and mapping. So there's a split in the community at the moment. So some considerations. There's no unique method. I will show you now some of the key methods that we think are pushing forward this technology. Different data are used by different groups, and this is an opportunity, but at the same time, we are not sharing the same methodologies. I have already mentioned very high resolution, less than 1 meter optical imagery are predominant in the literature, but synthetic aperture radar is rising higher in the agenda because there are papers coming out showing how to access this data, because in the past one of the problems was how to access this data. Although there were already several space missions providing also for free this data, and also how to process them. Interestingly, I will show you a case, especially in the second of these two talks, about the use of high resolution optical data. Interestingly, data with 5 to 30 meter spatial resolution has been perceived by the community as not useful as very high resolution. But I will show an example just to prove that this depends on the scale of mapping and on the size of the looting features. So we need to be more open-minded and not work with data just because we put higher emphasis on the spatial resolution. There's another key point, temporal frequency of observations, because looting is something very dynamic. I will show you an example in Epifani in Syria, and there you can see an increase of looting rates month by month. So you need data sometimes that are acquired very frequently, and not all the missions provide these for free or with no cost of reproduction. There were some barriers, I have to admit. Some of the very high resolution images are still very costly unless they are accessed through visualization platforms. The most common, Google Earth, but it has some limits, of course, because it's not frequently updated. It depends also on the area. You may have just 1 or 2 images. But there are some agreements with providers, but again, frequently they are very exclusive. So not all groups have access to large amount of this data. There are open access data. I will mention later on the Copernicus Sentinel-2 optical imagery at high resolution data that are free for everyone, but because they are at high resolution have been, for now, not used at all in the community. The community is actually moving from site-scale studies to more systematic regional efforts, because we have seen already in the previous presentation that, and in some of the previous slides, that looting is affecting entire countries. So we need to have diachronic and synchronic points of view of this phenomenon, especially at regional to national scale. One of the good things, especially in establishing methodology based on visual and manual mapping, is that we are aware of the sources of error. I will mention this later on, because identification of feature related to looting requires a lot of expertise, because I can tell you, and I will show some examples, they can be confused with other unrelated features. So this is important if we want to provide a quantitative estimate. So quantitative estimate means also sources of uncertainty and error. And as I said, there's a lack of evidence that methods are shared, and this is something that we need to work on. Let's start with the visual and manual methods, the most common. I just cite here the work by Sarah Parkak, probably you know her, from her very famous papers done in Egypt. They draw basically individual polygons over each looting pit. You can understand that this is a very accurate method, but it is also very time consuming, and because sometimes when you look at features, you have also to distinguish between real looting features and other features that are probably natural, like soil stains or plants that appear similar. You have also to consider that this quantification is the lowest possible count of looting pits. So it's a very conservative estimate. But this is done because there is, of course, an expert knowledge capable also to distinguish between older and fresh looting pits, because the looters tend to come back and repeat their action several times. So it's not a one-shot activity, I'm afraid. And if you have this continuous time series, like for instance in Google Earth, it's pretty easy that you miss some of the new looting features and miscalculate them, assuming that they are new, but instead they have already been made by looters in previous dates compared to the date of acquisition of your image. So, in my opinion, we are at the point where the expert knowledge trained by manual and visual methods needs in some way to feed into automated detection chains. Why this need? Because if we look particularly across the last decade, several groups have developed and published different methods, which, however, share some commonalities because they are based on spectral and morphological properties of looting features. I mean, in particular, the fact that looting feature in an arid environment has a different spectral signature. Is usually, as you have seen in the previous slide, a black hole surrounded by a lighter ground, and this is particularly important. I will show you in a second example in vegetated areas. Other groups have used the size, the circularity index. Unfortunately, my colleague from the National Research Council of Italy are not attending today's session because they have developed an interesting automatic method called Alfea, based on spatial autocorrelation and dissimilarity based on this variability along the edge. Interestingly, all the groups are developing their methodology workflows in commercial software. So meaning that the sharing of these methodologies is feasible because they can be shared in ArcGIS or in Envy. So it's interesting that there's the ground and scope here to disseminate these methods. We have seen case studies in arid environments, but looting is happening also in vegetated context, even in the Middle East. This is Apamea in Syria, and as you can see, there's a contrast effect, pretty distinctive, because looting holes appear as an alteration of virgin unexcavated soil. So we can use not only the visible bands that so far have been mostly exclusively used by groups in mapping looting features, so we can use also different channels. So the red and the near infrared also to derive some spectral indices, the very common spectral indices that we are quite used to use in archaeology, so EVI rather than NDVI. And as you can see, just an example, the false color infrared image just emphasizes and enhances the spatial spread and distribution of looting features. So maybe using different combination of bands and channels, we can also change the rationale for selecting data. Because if we know that a site is a heritage hotspot, interested by looting, we can also plan the acquisition with different rationales. In this case, even a seasonal approach where we know that seasonally the site is vegetated and we can have a better visibility of the features. And as you can see in this zoom detail, you can also differentiate between the older looting pits on the right with the fresh new looting holes on the left. Because we know, it's pretty known in the literature, weathering of these features are bringing this feature becoming less visible, even in very high resolution imagery. Spectral signatures are key at this stage, in my opinion. I just recall a paper that has been published in one special issue that we have edited last year by the Cyprus Technical University Group. And interestingly, not all spectral indices are adequate for all the cases. And that's something we need to work on. We may think that NDVI or EVI or leaf area index, because they are common indices, they work appropriately and successfully in every context. In this context, we are in a rocky, partially vegetated area in Cyprus, and interestingly, the group has developed some a complex methodology, including the use of vegetation indices, but they were basically derived from built-up indexes portfolio. I'm moving quickly about the optical high resolution data because the next talk will be focused also on the use of this data. Just to mention that the European Commission has a huge Earth observation program called Copernicus and Sentinel-2 constellation made of 2 satellites acquiring every 5 days every point on the Earth is providing for free this data. That in the visible and near infrared bands is at 10 meter and 20 meter in the SWIR bands. So you can imagine the type of analysis that we can do over large spatial coverage per single frame. So we can start even if not with the same detail in mapping as allowed by very high resolution data. We can do that, especially if we want a synchronic view of the various type of looting. I will present this case study in the next presentation. I'm just closing this first talk mentioning that there's also radar. Radar nowadays is providing a sub-meter to meter level data, both from the German and Italian Space Agency. I'm, of course, mentioning the Italian Space Agency constellation first. Also because we have an advantage, we have 4 satellites instead of 2 in the case of German Aerospace Center. And interestingly, we can reduce, because we have this constellation formation, the observation even to 1 day. So you can understand how we can task the satellite to very highly frequent observations. I will come back later on this, how looting features are observed in very high resolution SAR imagery, and how we have modeled the different appearance of looting goals depending on their size, orientation. This is also based on the evidence that particularly in the Middle East, these features are made by looters in a systematic way, using bulldozers in some cases or heavy machinery. So these features basically define some patterns, very distinctive patterns that we can also model and observe. In particular, just extracting the texture, because in radar, looting goals are an alteration of the surface roughness. So you imagine a virgin soil that has not been excavated yet is normally nearly flat. But if we have looting goals, this is an increase of surface roughness. And therefore, based on this geometric and morphological property, we are able to extract the position of new looting goals at very high detail, in this case at 1 meter resolution. And we can also build some interpretation keys that include not only evidence of new looting goals, but also backfilling and reworking. That's something that in the literature has been overlooked, because looters tend to repeat their action, and sometimes new looting goals backfill the previous ones. So I'm just skipping this slide and moving to the conclusions. So which are the levels at which we believe that we should work to disseminate these methods and going to the definition of best practices? First level, satellite data selection, because the evidence is that different groups are preferring different data, and this is mostly related to the specialist expertise. So who's able and more comfortable in using optical data tend only to use optical data, and vice versa, SAR data only. But we probably need to move towards combination. There are some open questions. In the table that I showed you with the automated methods recently developed by different groups, groups have tested these methods using different type of processing levels. Someone have used panchromatic, so the highest resolution possible. Others have put their emphasis on the spectral signature, others on the data fusion products. So that's something we need to work on. At the level of image processing methods, there's currently an emphasis in the community between who's working with automated methods and who's working with manual and visual methods. They are not exclusive. Our point is that visual and manual methods have established a correct and accurate methodology for mapping. We need to use this expert knowledge to better improve the automated detection chains, because of course, as Arianna recalled in the previous presentation, there are a lot of false positives in the analysis made with automated change detection. And finally, the outputs. I just showed you very quickly different ways to present the output of these observations. They are all equal. So I'm not saying that one is better than another one, but probably we have to think about if there's a need or an opportunity in attempting standardizing these outputs. So we took the same language and compared different case studies. Thank you.
Share this. Thank you. Thank you very much for this brilliant presentation. It has been extremely useful, especially because it has given you a very good overview of the situation of the current situation in remote sensing applied to the fight for against trafficking and looting of cultural heritage. Do you have any question about this presentation? Any question or comment? Yes?
I can shoot up.
You need it? Or?
No, yeah, I have a question concerning, it's not very technical, but does looting somehow correspond to demographic fluctuations? So easily said, if we have less people living in an area, does there appear more looting? Or if we have more people living in that area, there is some, clue in the data that was gathered to know?
Okay, this is something interesting actually, because already back in 2024, Stone published a very interesting paper on Iraq's situation of looting, correlating looting with population density. And the interesting evidence is that in most of the cases, looting occurs close to settlements and villages, because also we have to think about who's the player in making looting. Arianna said in the previous presentation that also common people, just for survival, is going to loot cultural objects. So, of course, social media and the recent political events have passed the message that there are some organizations, quite international, that basically drive looting. But we have also evidence since a very long time ago that also normal people tend to loot, but just because it's also a cultural phenomenon. In Apamea, the looting happened basically throughout the whole period, starting from the Syrian civil war. And we have, of course, evidence, particularly Jessica Zana from the United States, that this looting happened in relation to military occupation of the site and military and crime organization. But this is happening close to the town. So I would not say that looting is happening because the area is less populated. We have also examples in Egypt, very close to archaeological site. So not necessarily. I would say that where's less control or a different control, because in Apamea, for instance, we know that there was military control. So in that case, it was something that was allowed for other purposes.
Do we have any question? I have a question very quickly because I'm aware of time clearly. Most of the examples, actually, all the examples we have seen so far relate to quite remote area, and this connects very well to his questions. So, in your observation of papers and your own experience, what happens when we are speaking about the urbanized area? Or, I mean, not so remote areas like Middle East. I'm thinking about South Italy, Central Italy. We have huge problems there. We both come from Italy and we are aware of the situation. I assume that Spain or Greece might have the same problem as well. Surprisingly, maybe even England might have these kind of problems. So, what is, in your opinion, is still a good approach? Yes, it is. We know, but probably it's easier to to find out that looting is occurring just going by and somebody in the area noticing something strange. But what is your experience and what you have seen as experience of other scholars writing about the urbanized area or more central area in Europe or in other countries like US, Australia, and so on?
Yeah, that's again another key point. Yes, the evidence in the literature is that most of the groups are focused on remote areas, just because the inaccessibility, of course, favor the use of remote sensing. I'm aware also in the Middle East, but also in Western countries, that there are several incidents of looting. Interestingly, in urban areas, these methods are more challenging because I've showed you examples in extracting SAR texture rather than spectral signatures. An urbanized environment does have a spectral signature completely different, overlapping with those that may suggest the presence of looting. And also there's a problem, the visibility. More dense is the urban areas, less visible is the feature. I have an example in Bosra, south of Syria. It's a city, and we have seen some evidence of looting. But in that case, to be honest, with automated change detection, could not be detected because it could appear like a digging hole just in a garden. So that's something that we need to work more. And I think that in the Western countries, most of the studies have focused on the routes of traffic routes rather than spotting the areas, because unfortunately we know historically which are the areas looted. I mean, for instance, the UNESCO site of Cerveteri, close to Rome, in a very highly densely populated area, visited by tourists, and you never imagine, but it's still happening.
As well.
Exactly. Yeah.
Yeah. Okay. Well, thank you very much. So we move to the next presentation from Francesca Cignan and again Deodato Tapete, that is going to be presented by Deodato on assessing manual, unsupervised, supervised, and automatic change detection method for detection of looting in Apamea, Syria. Thank you.
Thank you. I will go quickly, also because I had already introduced some of the techniques before. Apamea is pretty famous, I'm afraid, for looting. I have noticed that also Arianna used as a background picture, because you will see in a second, Apamea was one of the first Middle East archaeological sites that basically come out in all the social media, because in 2012 was one of the first examples of looting happening as a consequence of the Syrian civil war. But starting from the beginning, Apamea is an archaeological site, very famous also for its beauty and the fact that it was built in the Hellenistic period in a very top position. So the strategic position of this city is distinctive, as you can see in these two digital elevation models, the Aster GDM, but also the 3 meter spatial resolution tandem maps dam generated with SAR data, and the high detail allow you also to identify some of the features, the anthropogenic features characterizing the site. The site, interestingly, is close to an artificial lake created by 3 dams. And before looting became the major threat for this site, actually, was the artificial lake the major threat because of the stability of the dams. The city was absolutely spectacular. Like all Hellenistic cities, had a very long Card Maximus with a fantastic colonnade, still surviving the ancient walls made by the Emperor Justinian, and also some areas like the theater in the bottom left. There was at that time waiting for someone rebuilding it. And as you can see, I was just mentioning before, in the background, you see Alcalat Medinico, which is a town, now a modern village. So just to say that this site is not isolated, is embedded in the Hama region, which is averagely populated. I've just reported that the sentence in the motivation proposed to UNESCO 30 years ago to propose Apamea to be included in the World Heritage Sites. It's in French, but you can understand probably the meaning. Apamea was proposed because it was still not fully excavated, and it was considered a huge reservoir of archaeological records. But unfortunately, this also was the motivation for looters. The situation prior to looting was this one. So in general, in the 30s, there were several archaeological missions that basically progressively excavated almost 40% of the site, which is the right side. That portion of the site is state-owned. The left side is privately owned land. That's a key feature to remember. Just Casana correlated this property situation with the temporal spread of looting. And you probably may think that the state-owned part was less looted than the privately owned land. But unfortunately, that's not true. In mid-2012, UNESCO called for international efforts to raise awareness of the situation, and the scale of looting was defined as industrial because it was made, as I mentioned before, with bulldozers and machinery. As you can see, they are repeated looting hole patterns, usually less than 1 meter deep, in some cases even a few meters. This depends on the looter's perception that they are going to find something. And with the planimetric shape that we used, as I showed very quickly in the previous slide, to model these features, to recognize them automatically in satellite data acquired in radar wavelength. So we used in the last 5 years a multi-sensor assessment of looting in Apamea, just to demonstrate that we can combine different methods and different data. So starting from a digital globe, the first appearance of looting was discovered with digital globe, so we visually identified the looting features and manual mapped them with high accuracy, finding exact match with other published papers. Then in 2014-2016, we used the staring spotlight data from the German Aerospace Center space mission called the TerraSRX, providing less than 1 meter resolution data. And we used the SAR texture extraction method that I showed you before, combined with supervised classification and a change detection that automatically provided the appearance of looting marks. Then we use Sentinel-2 because in mid-2015, Sentinel-2 data were accessible to the community with the first of the 2 satellites, and then in 2017 the second satellites satellite was launched, and therefore 5 days of temporal frequency of observation was reached in cloud-free condition. And finally, as we have our own Earth observation space mission, COSMO-SkyMed, which is equal to the TerraStar X1 from the German Aerospace Center, we are using this new data to continue tracking at high resolution the appearance of looting. So the manual mapping, basically, if you go on Google Earth, you will see this sequence starting from mid-2012, so exactly 1 year when we commonly say that the Syrian civil war started. Looting appeared in an unprecedented fashion, but this is because there was no spatial coverage with satellite data. So at a certain point, we found the evidence of this massive looting, but this did not happen likely in just 1 month. It happened throughout the period between the last image and the image in April 2012. So one of the first observations was that our perception of how looting rate is it depends also on the frequency of observation. At that time, in March 2014, we concluded that 44% of the total site was looted. And as you can see, the distribution is mostly on the right, on the eastern part of the site, which is state-owned. While the private owned land on the left, so on the western side, was not so heavily looted as the state-owned land. Interesting pattern that Jessica Zana commented very precisely, also in relation to the military occupation of the site. At the very beginning, I mentioned that this site was built intentionally at a very top hill position, and again, this was used during the wartime. We then moved in 2014 to look at the looting happening in Apamea in a project with the German Aerospace Center from 2014-2016 using 24 centimeter azimuth resolution data acquired every 2 months, so in a very consistent way. For the first time, this site was monitored regularly. So our assessment could be compared month by month. Using the very high resolution of this data, we were able, for instance, to extract the feature as the SAR texture, and this is not an enhancement. So it's not just a way to visualize better the data. This is the amplitude information, so the amount of data that comes back to the sensor from the object that has been illuminated on the ground by the space sensor. But in this way, we have extracted, with the calculation that I have reported before in the previous slide, the way looting holes alter locally the surface roughness. So it's a derived information that we can use in supervised classification to obtain a direct spatial extent mapping of looting. Of course, surface roughness can be confused between different features. I was mentioning before the false positive. So there's also a masking out step where you remove features that were already there and they were anthropogenic features or urban features that are not related to looting. And if you do that, 45% of the site was looted as of October 2014, with an increase of 1% between March and October 2014. So a gradual increase. We use then this amplitude change detection approach to distinguish the changes in amplitude signal from one image to the next one, identifying situation, the second column, of a new looting hole appearing as a distinctive pattern of increase and decrease of amplitude in the image. We had also reverse situation, looting holes that were backfilled, so we have the reverse spatial patterns of amplitude changes. a situation where we do not have changes at all, so that soil is still virgin and untouched, and also a sequence of systematic looting holes, because as I mentioned before, in this case, bulldozers and heavy machinery were used. Using these methods, relying on very regular time series, we could derive a dynamic mapping of looting. I was talking about outputs. This is one of the outputs that we can produce. So not only measuring the looting rate, but also how many looting holes are spread in a certain sector, and if there's a change. So it's a very dynamic process. You see that from October 2014 to February 2015, we had an increase of looting, and this is something real because we could compare on the same time interval in a consistent way. So with no interference in parameters of satellite data acquisition, but also interestingly, a different spatial spread. You see that looters from 2014 to 2015 moved to the eastern sector, again from the private owned land to the state owned land, going towards the areas where archaeologists since the 30s excavated houses, Roman houses. And again in 2015, an increase, and in this case a densification. So you see that looters not only change the areas where they loot, but they may concentrate on a certain area because they perceive that it's opportunistic to dig in that area, and they intensify their action. At the end of the period monitored with TerraSRX, we found a matching evidence with optical very high resolution data used by ASOR initiative in the southwestern part of the site, which was previously unexcavated, dedicated just to pasture, close to the theater. But as you can see, the combined use of SAR texture and spectral signatures in optical very high resolution images can show you the advantage of combining these two data, because SAR texture in this case was able on the eastern side, so on the left side, to see rejuvenated looting in a previously looted area, which was not so clear in the optical image if you compare the contrast in the spectral signature, just in the visible bands. Moving to 2015-2017, we realized that Sentinel-2 could be used in this case. We know that the high resolution to 10 meter is not allowing the same fine detail mapping as a very high resolution image, like a commercial image from Digital Globe. But in a case like Apamea, where looting is so extensive, we can use Sentinel-2, which is free, and it's very highly repeatedly acquired every 5 days if there are no cloud coverage, to see if there's an opportunity to zoom in with purchased very high resolution imagery. So Sentinel-2 could be used also to plan even more investigation at higher resolution. This is the southwestern part, and as you can see, is astonishing even at high resolution, the extent of spreading of this phenomenon just in one area. And this matched exactly with the nearly coeval, very high resolution image from Digital Globe. So that's an example to demonstrate that not necessarily we need to use straightforward the very high resolution images, which are costly and if are not accessed through agreements, so waived from the costs of reproduction, we cannot map in detail the extent of looting. So it's a combination and integration. I'm not saying that we need to replace a very high resolution with high resolution, but I'm saying do not discard the possibility that Copernicus Sentinel-2 is offering. Another example, I mentioned before that looting holes tend to weather because they are exposed to weathering processes. So with this method, because we have a very highly temporal frequency of observation, we can observe not only the spreading of looting, but also measure the uncertainty that this continuous time series at very high resolution could bring if we do not track along over time the spreading of looting as well as the weathering. Because as you can see in the bottom left image, in April 2016, we were able to map that spot, that nearly circular spot of new looting that in May 2017, after 1 year, seems not present anymore. But that's not true. It's still there, it's only weathered. So at this resolution, which is coarse, of course, we could not capture that. But if we have a very detailed and frequent time series, we cannot miss areas that have been already looted. Just to conclude, we are doing the same stuff with COSMO-SkyMed as we did with TerraSerex, and I'm afraid looting is still happening. This is an image from last month. Just coming back, you see in May 2017, looting was above the second main decumanus, the straight line crossing the Cardi Maximus. So at that time in 2017, looters did not reach these houses, but now they are. In blue, you see the effect of surface roughness due to new looting. So it's still happening and we are still monitoring. So to conclude my presentation, for the Epifani case study, we can make some conclusions. After these 5 years of monitoring, we can say that looting has never really stopped. But the phenomenon showed different patterns. It changed not only in severity and frequency and spatial distribution, but also in typology. Most happened in 2012, 2014, but our vision of the progress was hampered by the discontinuous time series of very high resolution data in Google Earth, which were not so frequent. In 2013, 2015, we have more evidence of reworking and repeated looting rather than a real expansion of looting. Starting from 2015, instead of looting again start to spread in new sectors, particularly in the southern parts of the site, reaching also some excavated areas. The lesson learned from testing different methods, visual identification and manual mapping, they have clear pros, accuracy based on the expert knowledge. It's very difficult to misclassify a looting feature with soil stain rather than plants or other anthropogenic features, but it's very time consuming. SAR texture and supervised classification have the advantage that objectively we can extract this surface roughness property of the looting holes and see where looting holes as an alteration of the virgin condition is happening. But of course there are some false positives, especially if we are in an area where we have also other type of features, like urban features. So we need to remove them. So at some point, these automated methods require manual adjustment towards the end of the chain. SAR amplitude change detection, again, is an objective method. There's no visual identification. It's just based on the objective recognition by the software that amplitude has changed. But there may be some interference factors like soil moisture. Sentinel-2 images. My recommendation is not to forget that there are also this type of facilities now. So we need to be open-minded and think that this data could be a way to screen this type of sites where looting is extensive. Of course, if you are searching for individual looting pits, Sentinel-2 is not adequate. But if you have already a hotspot where you know that looters are repeatedly looting the site, of course, this could be a way to quickly search for evidence and then plan a targeted campaign. Finally, spectral indices. As I said, they can improve the way we delineate in an automated way looting features, but depends on the actual environmental conditions, like if it's a rocky environment, a vegetated environment, if it's a type of looting goal with a certain size, with a certain property, if these indices work well. So we need to test. And if you want to know more about all these methods, these are the references, and I'm available to share the papers. And with that, I thank you for your attention.